All right, good morning, folks. We're going to get started with our final three Hyperwall talks of the 2017 AGU. So my name's Steve Graham. I'm from the Goddard Space Flight Center, and I'm going to be talking to you guys over the next 15 minutes or so about a new Earth at Night product that NASA produced. But before I go any further, I'd just like to also say that I'll be followed up by Brian Day, who is going to give a nice overview of the Mars Trek application, which enables you to fly around Mars and check out the surface of Mars with a really neat web app that he helps develop. And then following Brian will be Ali Omar, who will be talking to us about air quality observations from NASA satellites. And then following Ali's presentation, we're going to show a feature documentary film. You may have seen it or heard about it, Before the Flood, which is Leonardo DiCaprio's documentary, which nicely features a lot of NASA data, NOAA data, USGS data, and also prominently features our past Earth Science director at Goddard, Dr. Piers Sellers, who is also a former astronaut. So we'll be showing that documentary film at about 10:45, and it's about a 90-minute film if you guys want to stick around and watch it. Okay, so let me get started. So again, this is the Earth at Night. This is a product that's been around for many years now, and you see the date up in the upper right there. This is a product from 2003. So this is produced. This particular global map was produced from the DMSP series of satellites, the Defense Meteorological Satellite Program, which was started back in the late 60s, early 70s. And DMSP is a DoD polar orbiting satellite, and on the DMSP satellite was a sensor called the Operational Line Scan System, or OLS. And OLS was one of the first sensors to have the sensitivity to view the Earth at night on cloud-free nights, and taking lots of cloud-free swaths of data. The visualizers were able to come together and stitch all these different swaths of data together to come up with this beautiful composite of the Earth at night. The spatial resolution of the OLS was about 3 kilometers, so it's not quite as good as what we have now from the VIIRS, which I'll show you in the next slide here. And so on the left here is a sample of the East Coast from the DMSP. So this is a little bit blown up, but it kind of gives you a feel for the coarse resolution of the DMSP. But you can certainly make out the city lights along the eastern seaboard. Of course, you know, Washington, D.C., New York, Boston. D.C. is over here. Here we are in D.C. New York is right here. And then back in October 2011, NASA NOAA launched the SUMI MPP satellite, which carries an instrument called VIIRS, the Visual Infrared Imaging Spectroradiometer, or VIIRS. And on VIIRS is a band combination called the day-night band, which is a lot more sensitive to the Earth's city lights as compared to the OLS. And in fact, the maximum spatial resolution of VIIRS is 750 meters. And of course, VIIRS is much more sensitive, about 15 times more sensitive to the city lights than OLS was. So the first iteration was released back in 2012, and then in 2016, Dr. Miguel Ramon from NASA Goddard reprocessed the data, and he did so by taking out all of the natural sources of light. So all of the reflected moonlight, all of the aurora effects, as well as air glow. And so we really just get the man-made sources of light. And so here's that first iteration from 2012. So this iteration includes, again, the reflected moonlight, includes the air glow, includes the aurora, as well as all the man-made lights. And then 2016, it was reprocessed to remove all those natural sources of light. So now we're just seeing all the man-made lights around the world. Let me go back to 2012. Can anybody notice any subtle changes in lights between 2012 to 2016? They're subtle, and of course we're looking at a global view here. And so when we compare the two, 2012 to 2016, now we get a nice change map. And so the scale is down here in the bottom left, where orange are where lights have gone out around the world, The white areas are where there's basically been no change of lights, and then the purple areas are where we have new lights around the world. And so the next few slides, I'm going to highlight some different areas around the world where lights have changed dramatically over the last 4 years. So I'd like to start out with the Indian subcontinent. So here's most of the subcontinent of India back in 2012. You can see some of the major cities highlighted here. And then as we go to 2016, you can see the major differences, especially between New Delhi and Kolkata. So these data are used by scientists and decision makers to monitor these changes in urbanization. And so the images here between 2012 and 2016 show the rapid electrification of India's rural settlements, particularly in between New Delhi and Kolkata over the last 4 years. So this section of India up here was relatively dark in 2012, and now you can see this huge electrification initiative that has gone on over the last 4 years in India, and all those lights. And so I'll show you the change map as the final image. So all those purple areas here are highlighting where India has become electrified. So basically, all these rural areas that didn't have a lot of lights have become much brighter over the last 4 years. The next part of where I'd like to go to is the Eastern Mediterranean. We're all familiar with the unfortunate civil war going on in Syria. And so here we have Damascus and Aleppo at the top here, and also call your attention to the Euphrates River up there and how many lights are there back in 2012. Unfortunately, with the war going on, many people have fled. About half the country has fled Syria. And so now you can see Aleppo is much, much smaller, and even more amazing is all the lights that were along the Euphrates River are now gone. And so here's that change map. So again, all those orange areas are showing where all the lights have gone out in Syria. So Syria was a major power source for the Eastern Mediterranean region. Had about 15 power stations and 3 hydroelectric dams that have almost all gone out over the last 4 years. It's also interesting to note up at the top here, you can, in the 2016 image, you can almost make out the border of Turkey, all those lights at the top there, and you can see make the comparison here to 2012, whereas that delineation is not quite there. So it gives you a feel for how many folks have moved north into Turkey from Syria. The next comparison I'd like to show you is Western Africa. So here's Nigeria. Lagos is right here, and you can see all these lights here, and this is all gas flaring from gas fields and oil rigs. And you notice that the signature of these lights is quite different than the city lights. So you can see it's more diffuse, and that's how we can tell these are actually gas flaring light sources as opposed to lights themselves, street lights or urbanization lights. And then in 2016, a lot of this flaring has been reduced. And so here's the change map. So again, all those orange areas showing the reduction in flaring. And so this was basically due to an international agreement that they decided that they're going to reduce their emissions from these flaring in this part of Africa. And then finally, the amazing difference between North and South Korea. So you can clearly make out the DMZ here, which is that bright line at the top of South Korea here. Of course, Seoul is that big bright object just south of the DMZ, and of course Pyongyang, the capital of North Korea, that very faint light. So South Korea has about 49 million people in it. North Korea has roughly half that amount, but of course they don't quite have the lights on like South Korea. And here's the 2016 image. And so the other interesting thing about this image is all these lights just off the southeast coast of South Korea. And so all those lights are fishing fleets. In fact, you can see lots of fishing boats off this southeast. Whoops. There we go. So all these lights here are all the fishing fleets. And then you can see this interesting group of lights here. These are all fishing boats as well. You can see how they're in this line here, this international fishing boundary. So the boats are allowed to come here, but not to here. But then in 2016, all those lights are gone. So apparently perhaps some sort of illegal fishing was going on here, and we're able to see those. So these data sets are actually being used to monitor illegal and unregulated fishing across the world. And so finally, here's the change map. And so again, all the orange where the lights have gone out. Lots of fishing fleets have changed their positions over the last 4 years, and especially this line here just south of the island. So lastly, just want to give credits to the folks that processed this imagery. So, of course, Dr. Miguel Roman from NASA Goddard, he leads the team that reprocessed all of this data. Josh Stevens worked with him very closely to produce these beautiful, beautiful images. And of course, Heather Hansen, who helped write a lot of the text that goes with these images. Incidentally, we've had a poster. I don't know if you've been able to pick it up this week. We're handing out a poster of the Earth at night. So all the data that I've shown here is on the back of that poster. And so next year, we hope to be handing out a small booklet showcasing not only this imagery, but lots of imagery of other places around the world, making comparisons between 2012 and 2016. Thanks very much.